Hello, good day, our beloved and respected followers. This question here says, assuming the weight of this black 32 meters beam is negligible, what is the force that must be applied at this point A to make the beam lie directly on the horizontal axis? So how can this be solved? Well, let's see. Since we are assuming that the weight of the beam is negligible, that means the reason why this end is on the ground is because the weight of this 2.8 kilogram stuff is causing a moment at this point here, let's say P, by pushing the beam downward at this end. So for the beam to be balanced horizontally, we need a counter moment at this P, that is a moment about this point P with the same magnitude as the moment caused by this stuff here, but in the opposite direction. So let's write it out here. Counter moment equal to moment caused by 2.8 kilogram. And from the question, we are asked the magnitude of the force to be applied here to balance the beam horizontally. That means it is the one causing the counter moment. Now let's assume that we have the force now and the beam is lying on the horizontal axis already because of the force. So let this counter force equal to Fc. But what is the moment caused by this force at point P? We don't know. But formula for finding moment is force times perpendicular distance. Force is Fc. We can see since Fc is vertical and the beam is horizontal, that means this 8 meter is its perpendicular distance from this point P. That is perpendicular distance equal to 8 centimeters. Substituting here now, counter moment equal to Fc times 8 meters, which is 8 Fc meters. Now what is the moment caused by this 2.8 kg? 2.8 kg is the mass of the stuff. The force caused by this 2.8 kg mass is a weight of 2.8 kg times 9.81 meters per second squared, which is 27.468 kilogram meters per second squared. Kilogram meters per second squared is equivalent to 1 Newton. So force caused by 2.8 kg is 27.468 Newton. We are not given where exactly or at which point this force is acting. We just assume it's a uniformly distributed load, that is, the force is acting here at the center. Now what is the moment caused by this force at this point here? We don't know, but moment we know is force times perpendicular distance. Force is 27.468 Newton. Since the gravitational force is vertical and the beam is lying horizontally, that means the length of the beam from this point to this point is the perpendicular distance. So what is the length of the beam? We don't know. But recall here, the whole beam is 32 millimeters in length. So since from this point to this point is 8 meters and from here to here is 7.6 meters, that means from this point to this point is 32 meters minus 8 meters minus 7.6 meters, which is 16.4 meters. Now from this force to this point is half 7.6 meters because it's acting at the center of 7.6 meters. 1 over 2 times 7.6 meters is 3.8 meters. Now perpendicular distance is 3.8 meters plus 16.4 meters, which is 20.2 meters. Substituting here now, moment caused by 2.8 kg is 27.468 Newton times 20.2 meters, which is 554.8536 Newton meter. Now we have counter moment equal to 8 Fc meters and moment caused by 2.8 kilogram is 554.8536 Newton meter. Now substituting here now, 8 Fc meters equal to 554.8536 Newton meter. Dividing both sides by 8 meters, 8 Fc meters over 8 meters equal to 554.8536 Newton meters all over 8 meters. Here, 8 cancels 8 and m cancels m, while here also m cancels m and 554.8536 Newton over 8 is 69.3567. So Fc equal to 69.3567 Newton. That is 69.3567 Newton is the force that must be acted here against the weight of this 2.8 kilogram stuff to keep the beam lying horizontally, assuming the weight of the beam is neglected. Thank you for watching. Please comment, like and share. Also don't forget to subscribe. Thank you.